You know that feeling when you're frantically searching online for a very specific item?
Like a replacement part or something.
Yeah, exactly. Like a replacement carafe for your exact model of coffee maker. You hit search, and the engine just confidently recommends a toaster.
Right, or the exact carafe you need, but it's been out of stock since 2019.
Yes. It feels like arguing with a stubborn friend who absolutely refuses to admit they just don't know the answer.
Because the system is trying to be helpful, but at a certain level, it's fundamentally guessing based on patterns rather than hard facts.
And that guessing game is exactly what we are tackling today. We're looking at a massive breakthrough from Google DeepMind and YouTube called the static framework.
It is a brilliant piece of engineering.
It really is. And the mission for you listening to this deep dive is to understand how this prevents AI from hallucinating invalid search results. It makes recommendations insanely fast and hyper-accurate.
So the root of the problem comes from how industrial recommendation systems are evolving right now. The industry is shifting toward generative retrieval.
Right. Instead of the old methods of just searching a database.
Exactly. Platforms are using large language models to find items. The AI represents every product or video as a unique token sequence called a semantic ID.
And it attempts to generate the right ID for you on the fly.
Right. But because it's an LLM, it naturally hallucinates. It will just confidently spit out a semantic ID for an item that is entirely invalid.
Or completely out of stock.
Exactly.
So I saw in our sources they used to fix this with something called a Trie, spelled T-R-I-E, like a prefix tree, to block the AI from choosing bad tokens.
Right.
But apparently modern hardware like GPUs and TPUs absolutely hate that method. Why is that?
Well, think of navigating like walking through a maze blindly.
Yeah.
You take a step check if it's a dead end and then decide your next move based on that check. It forces the system into unpredictable branching.
Which chips hate right.
Totally. Modern accelerators are built to do one thing incredibly well, and that's process massive, predictable blocks of math all at once. Jumping around a messy tree creates memory latency.
It breaks the static compilation graphs those chips rely on.
Exactly. And that is where the static framework comes in.
The sparse transition matrix accelerated Trie index.
Right. They figured out how to take that entire unpredictable maze and flatten it into a static compressed sparse row matrix, or CSR.
So it acts like a top-down map instead of a blind maze.
Matrices are the native language of GPUs. By turning the safety rules into a matrix, the AI can process the guardrails at the exact same time it processes the search query.
It translates a chaotic step-by-step journey into a single, hardware-friendly, vectorized math operation.
Spot on.
Speaking of building systems that actually work with your hardware instead of against it, if you are looking to integrate AI agents, automation, or custom software into your own workflow, you should check out our sponsor, Embercell.
They do great work.
They do. Uncovering where agents can make the most impact for your business or personal life is exactly what they do over at embercell.com for all your AI needs. So getting back to static, seeing the real-world impact of mapping AI constraints this way is wild.
It really is. When they deployed it on YouTube to enforce a strict last 7 days freshness rule for video recommendations, it achieved 100% compliance.
Wow, mathematically stopping the AI from hallucinating older videos.
Which actually drove a 5.1% increase in fresh video views.
That is huge. And it solves the infamous cold start problem too, right?
Yes. In tests using Amazon Review's data sets, the system successfully allowed the AI to recommend brand new items that the model had never even seen during its training phase.
Hold on. I want to talk about the sheer speed of this thing because the scale of the improvement is staggering. Static achieved a 948 times speed up over CPU offloaded tries.
It brings the process down to just 0.033 milliseconds per step.
And it manages to do all of this while using a tiny memory footprint. What was it? Roughly 90 megabytes per 1 million items?
Yeah, something incredibly small like that.
Incredible.
The overarching takeaway here is incredibly optimistic. It proves that we do not have to compromise between speed, power, and reliability.
We are actively solving the hallucination problem at an industrial scale,
showing that we can make AI systems both highly creative and flawlessly constrained.
Which leaves you with a final provocative thought to chew on today. If we can mathematically flatten complex logic to instantly constrain AI recommendations without slowing them down, what other unpredictable AI behaviors could we perfectly tame next using this exact same trick?
It's a very exciting frontier for the future of artificial intelligence.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.